In this video, we're going to be discussing the concept of a hyperbola. A basic understanding of what a hyperbola is and how the points are formed is up here on the left-hand side. And it says the difference between the distances from each foci to a point on the hyperbola is constant. So let me plot a couple of foci for you here. And we'll just label that one focus. And this is another focus. And what's happening here is if you pick any point, let's say maybe this point right here, and you were to find the distance between this focus and this focus all the way across, and if you were to take those two distances, subtract them, or find the difference between them, it wouldn't matter if you picked a point here, 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 or really anywhere on the hyperbola. If you took each one of those distances and found the difference, it would actually be the exact same thing. When we're discussing a hyperbola, we want to start with the center. So if you take a look here, right in the middle of the vertices, so we can actually label each one of those. This is going to be, I'll just put a C for the center, and this is going to be a V for each one of the vertices. The center is directly in between each one of the vertices, and there's a special line that the center of the vertices and the foci all line up on here, and so I'll try to draw this dashed here. Of course, this is not really part of the hyperbola, it just helps us to understand it, and that is called the transverse axis, the whole thing. And if we were to go in the other direction, actually, that would be another axis, and again, this is going to be different than an ellipse. Ellipse, you got like major and minor. But here with a hyperbola, we have the transverse axis, which is where kind of all the interesting stuff is happening. And this other axis here is called the converse axis. If we're to look at the values of A, B, and C, kind of similar to an ellipse, we can look at this value between the center, or the distance between the center and one of the vertices, and that's still going to be A. And then also, the distance between, I'll use purple here, try and keep with the color scheme, the distance between one of the focuses, or the foci I should say, that's still C. Please note though in this case that C is bigger than A. The foci lie away from or outside of each one of the vertices. With an ellipse they lie inside the vertices, but this is a different situation. B is a little bit more interesting to take a look at. It doesn't lie on the hyperbola, it's kind of out in the middle of nowhere here. But B is going to be this distance here. And I'm just going to make a mark there. And that distance is B. And this distance down here would be also B. Now you might be wondering, why do we even need to know B? I mean, if we got A and C, we have the hyperbola. And we need to know B for this reason. A hyperbola actually, even though it looks like a couple of parabolas, even though the shape sort of looks like that, a parabola would kind of curve up a little bit more right here. A parabola doesn't have any asymptotes. A hyperbola, though, does have asymptotes. So to find those asymptotes, what you can do is you can take kind of like a box-like approach here and make a rectangle. And what we're going to do is we're going to take a look at one of the vertices. We're going to draw a vertical line here right through each one of these vertices. And then at B, whatever B is, you can go ahead and draw another line right here, and you can form a little rectangle. And at the corners of these rectangles, which by the way, if you drew a line through each one of these corners, it'd go right through the center, you will find that each corner to the opposite corner, those will form this wonderful graphing helper called an asymptote. And so the edges of the hyperbola will get close to, but not cross, each one of these asymptotes. So these are really, really nice to be able to see if I can draw this. Okay, it's going to come this way and keep going. Right. So the hyperbola is going to come up to and get really close to each one of these asymptotes. Super awesome to be able to draw. So a lot going on here. We've got the transverse axis, kind of, I guess, like the major axis for an ellipse. The converse is sort of like the minor, I suppose. But we don't name the major or minor because actually the distance here, A, could be less than B. However, C is always bigger than A. So look for the next video. Look there to check out some of the equations, and we'll take a more analytical approach in those videos.